Yes, good morning everyone. I hope you have completed your yesterday's assignment in which you had considered solvent as your solid phase and solute as your solid or liquid or gas. So this homework examples of homework related aspect I hope you have written it. Okay. Once you will be coming here, you will be submitting it. So next concept, okay, yesterday I said, okay, when you have to separate among two components, that is A and B, among two components A and B, among these which is solute and which is solvent, in order to understand, we have to know the concentration of individual components. Concentration of individual components. Concentration means ಅವರ ಪ್ರಮಾಣ ಎಷ್ಟಿದೆ ಅಂತ ನಿಮಗೆ ಗೊತ್ತಿರಬೇಕು. A ಎಷ್ಟಿದೆ, B ಎಷ್ಟಿದೆ. ಅಂದ್ರೆ ನಿಮಗೆ A ಎಷ್ಟಿದೆ, B ಎಷ್ಟಿದೆ ಅಂತ ಗೊತ್ತಾದ್ರೆ then you can tell among these two which is solid and which is solvent. So ಈ ಪ್ರಮಾಣವನ್ನು ಕಂಡುಹಿಡಿಯೋದಕ್ಕೆ ನಾವು ಹೇಳ್ತೀವಿ concentration. The concentrations are of two types. Concentrations are of two types. The first type is, as I would say it as, these are temperature dependent. These are temperature dependent. Whereas the next two are, the next quality is mass dependent. Temperature independent. Next one is temperature independent. Temperature independent. Okay. So what do you mean by temperature dependent or temperature independent? In order to understand, you should know the classification that any substance is having two qualities. Okay, any matter is having two qualities. It is having a mass and also it is having certain volume. It is having what? Matter is nothing but which has mass and which occupies some volume. Now you have to understand, among this mass and volume, which is temperature dependent and which is temperature independent. For this to understand, I will give you a better example. Okay, suppose if I take a wooden plank of 10 kg, or a stone of 10 kg at 25 degrees Celsius, okay. Now what I will do is, I will take the same 10 kg bag at 35 degrees Celsius. Does the mass change? The mass will not change, because the 10 kg mass, whether it is at 25 degrees Celsius or whether it is at 35 degrees Celsius, will remain the same. So इसका मतलब the concentration terms are temperature independent, means they will be depending upon mass. They will be depending upon what? Mass. So therefore the concentration terms which are temperature independent are governed by mass. ಅಂದ್ರೆ ನಿಮ್ಗೆ ಏನಾದರೂ ತೂಕ ಅನ್ನೋದು ಏನಾದರೂ ಇದ್ರೆ ಅದು ನಿಮ್ಮ ಟೆಂಪರೇಚರ್ ಅಂದ್ರೆ ತಾಪಮಾನದ ಇಂಡಿಪೆಂಡೆಂಟ್ ಆಗಿರುತ್ತೆ. ಅಂದ್ರೆ ಅದು ಯಾವ ತಾಪಮಾನದ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರೋದಿಲ್ಲ. The mass does not depend on the temperature. Okay, the same thing if I consider volume, okay, like a gas at 10 ml, okay, ideal gas which is at 10 ml, it is at temperature T1. Okay, this is an ideal gas, okay, जिसका volume है V1. Now if I increase the temperature to T2, you know that according to the gas laws, the volume will increase to what? V2. So you have a famous law, at constant pressure volume is directly proportional to temperature. इसका मतलब when temperature increases, volume will also increase. When temperature decreases, volume will also decrease. So you see that there exists a relation between temperature and volume. इसका मतलब the volume is dependent on temperature. So concentration terms which are temperature dependent are governed by volume of the substance. So if you are considering a solution, if the solution is having components which are having purely based on your mass, then you call them as temperature independent. If they are governed by the volume, then they are called as temperature dependent. This classification is not there in your textbook, but you have to understand what are temperature dependent and what is temperature independent. Now you have to see the concentration terms that are given in your textbooks. The first one, okay, when you go for mass, so it is given as
mass by mass percentage. Okay, it is given by mass percentage. Okay, mass by mass percentage. Then next, same way here first one will become volume by volume percentage. Volume by volume percentage means what is mass of the solute, what is mass of the solution into 100. Okay, I'll just write here. Okay, this simply means mass of the solute divided by mass of the solution into 100 will give you percentage mass of solute. Will give you what? Percentage mass of solute. In the same way, if you calculate, okay, mass of the solvent divided by mass of the solution into 100 will give you percentage of solvent. So this is equal to solute percentage, okay, and this is equal to solvent percentage. Okay, so sum of these solute percentage plus solvent percentage will be equal to what? Will be equal to 100. That indicates what your complete solution. The same thing applies on this side. The same thing is going to apply on this side. That is volume of the solute divided by volume of the solution into 100 will give you solute percentage. Same way, the solvent percentage is equal to volume of the solvent divided by volume of the solution into 100 will give you volume by volume percentage. The sum of the solute plus solvent will be equal to 100. So how can I define what is mass percentage or volume percentage? It is mass of a component. Instead of saying it as solute, I will simply say it as mass of component A divided by mass of A and B. Same way, this will act as component B. This is going to act as component B. ಇದೆರಡರಲ್ಲಿ ಯಾವುದು ಪರ್ಸೆಂಟೇಜ್ ಜಾಸ್ತಿ ಬರುತ್ತೆ ಅದು ಸಾಲ್ವೆಂಟ್ ಆಗುತ್ತೆ, ಯಾವುದು ಪರ್ಸೆಂಟೇಜ್ ಕಡಿಮೆ ಬರುತ್ತೆ ಅದು ಸಾಲ್ವೆಂಟ್ ಆಗುತ್ತೆ. The same thing applies. Instead of writing solute, I can write here it as volume of component 1, volume of component A. Then I write volume of component B. Okay. So after calculation in any arbitrary numerical, if you get this component, percentage of component A, assume it to be what? I will say it as 55%. Okay, the solvent percentage will remain as 45%. Okay, after calculating what, if you take component A volume, then component of volume of the solution. If you take volume of component B, then volume of the solution. After doing this, values will be given to you people. Component A value will be given, component B value will be given to you. If it is 55%, then you call this as solvent because this is present in larger value, and this you will call it as solute. That is why I said among A and B are to separate what is the solute and what is the solvent. That is purely depend upon this. Calculation. Once you get into the numericals, there you will understand. So this is the first one, that is volume by volume percentage, then mass by mass percentage. Remember, the volume by volume will be temperature independent, whereas mass by mass is temperature independent. The next one, which is classically we fall again in this one, that is mass by volume. Okay, which is mass by volume. How to define? So this is equal to mass of the solute divided by 100 ml of solvent. So this is nothing but your mass by volume. Okay, so this is the overall view of your mass by volume. Now let us get into, okay, most of the time you will be having questions on these in the numericals, you will be having mass by volume percentage only. where you will consider the mass, then you will be considering what volume. Suppose if the mass is given, I need to calculate the volume, then you can simply use the formula density is equal to mass by volume. If density is known, then volume is known, you can calculate the mass. If mass is known, density is known, then you can calculate the volume. So these are interdependables. These are what? Interdependables. So this is regarding mass by mass percentage. Okay, volume by volume percentage, then mass by volume percentage. Now let us go to your next part. Okay, where you are considering the mass as the main criteria. So here it will be molality. Here it will be what? Molality. Here it will be what? Molarity. Here it will be what? Molarity. So you have already learned this. What do you mean by molarity and molarity? Molarity simply means it is the number of moles. It is the number of moles of solute divided by 1 liter of solution. 1 liter of solution. So this is nothing but this is number of moles of the solute. Number of moles of solute. So how to calculate number of moles? Number of moles is equal to given mass divided by molar mass. Divided by what? Molar mass. So if you calculate the n, then the n value present in 1 liter is equal to what? Your molarity. Now if you focus here, this 1 liter is nothing but this is volume. So therefore this is going to fall under temperature dependent. This is going to fall under temperature dependent. Then the next one, molarity. How to define molarity? This is number of moles of the solute in 1 kg of solvent. 1 kg of solvent. So if you clearly see, here you have what? Mass. Here you have what? Mass. So again same formula where n is equal to given mass divided by molar mass. Given mass divided by molar mass. For example, I will say, okay, if I say 100 ml of water, 100 ml of water. Okay, calculate the number of moles in 100 ml of water. So they are given you the volume. When you want to calculate number of moles, you should have what? It should be in terms of mass. So this 100 ml, I must convert it to mass using the formula density is equal to mass by volume. Okay, density of water is equal to 1 divided by m into volume is 100 ml. 100 ml. So therefore this will be 100 ml. So 1 I will not write it just like this. I will write as 1 gram per cubic centimeter. 1 gram per cubic centimeter. Therefore m is equal to, if you transfer it on this side, 1 gram C per cubic centimeter is equal to what? Milliliters into 100 ml. The milliliter and milliliter will get cancelled. So therefore it is 100 grams. Therefore it is what? 100 grams. So now you got the mass, that is the given mass is equal to 100 ml. So therefore given mass is 100 grams. You know the molar mass of water, that is H2O, is equal to 1 into 2 is 2, and molar mass of the, atomic mass of the oxygen is 16. 2 plus 16 is equal to 18. So this is 18 gram per mole. 18 gram per mole. So I will write it. Molar mass is equal to 18 gram per mole. So therefore gram and gram will cancel. 100 divided by 18 is equal to 5.55 moles. 5.55 moles. So this is how you calculate your number of moles. So once you calculate the number of moles, if the solvent is given in kgs, you can convert it to volume. If the solvent is given in volume, you can convert it to what? Kgs. Okay, this is the formula where mass and volume are interconvertible, provided if the density is known. Provided what? If the density is known. So I think this is clear to you people. Okay, the next one we have to focus on. Next we are focusing on, here on this side we are focusing on the next one, that is normality. Next one is normality. Here I will be considering mole fraction. Here I will be considering what? Mole fraction. Then here I will be considering a new term which is called ppm. Which is called ppm. Okay, or you can even call it as ppb. You can even call it as what? ppb. So let me define what is normality. It is not of importance to your theory exam. but this is required for your competitive exam. This is required for your competitive exam. So normality is defined as it is the number of equivalent weights present in 1 liter of solvent, 1 liter of the solution. Now how to calculate the equivalent weight? Equivalent weight is given by molar mass divided by number of the electrons involved in the reaction. Number of electrons involved in reaction divided by volume of 1 liter of the solution. Now in order to understand what we mean by number of electrons involved, you should be having thorough knowledge of redox reactions. Okay, in the redox reactions, you know that the combination of the reduction and oxidation is called redox reaction. What happens? What do you mean by oxidation? It is nothing but loss of electron. Then what do you mean by reduction? Okay, this is called gain of electrons. So in these cases, the number of lost electrons is equal to number of gained electrons. So therefore, I must be knowing how many electrons are involved. For example, if you have seen, okay, chromium ore, okay, in the compound Cr2Cr2O7, where this is present in 6 plus, this will be converted to Cr3 plus. So this shift is number of electrons is involved is what? 3 electrons are involved. So therefore, those number of electrons will be involved. Once you get into the chapter, once you get into the competitive numerical, there I will be explaining. But as of now, remember, this is only used in your competitive exams. It will not be considered in your theory exams. In your theory exams, we are considering mass by mass, volume by volume, mass by volume, molarity. Then we are considering these two parts. But this is of competitive importance. There I will explain. So this is equal to equivalent weights present in 1 liter of solution. Equivalent weight is equal to molar mass divided by number of electrons involved is divided by 1 liter of the solution. Now let me focus on the important aspect, that is mole fraction. Suppose if there is a component A and B, if the component A and B are present, let number of moles of A be and A, let number of moles be and B. Then XA is equal to number of moles of components A divided by total number of moles Then similarly XB is equal to number of moles of components B divided by number of moles of components A and B. Remember, okay, XA plus XB, if you are calculating, okay, this is equal to NA divided by NA plus NB, okay, plus NB divided by NA plus NB. By your simple basic mathematics, I write NA plus NB divided by NA plus NB. So these will cancel each other. So therefore this is equal to 1. So I write the sum of the mole fractions in a system, sum of mole fractions in a system of solution mole fractions is always equal to 1. So therefore if I write, okay, now let us XA plus XB is equal to 1 means I can write XA is equal to 1 minus XB or XB is equal to 1 minus XA. इसका मतलब if XB value is given, you can calculate XA. If XA value is given, you can calculate what? XB. Please remember this formula. This is most important for your rest numericals. Okay. So this is regarding the concept that you have already learned. Okay, that is molarity and mole fraction. Let me go for last concept, that is parts per million. This parts per million, okay, this parts per million or parts per billion or parts per billion. See, I have, this is abbreviation form. ppm का मतलब होता है parts per million. parts per million, or it is equal to parts per billion. Now these two terms, terminologies, that is parts per million or parts per billion, are being utilized for your very dilute solutions. These are used for your very dilute solutions. These are used for dilute solution. For example, if there exists component A, if there exists components A and B, okay, therefore number of components of A in 1 million particles, solution particles. So this is equal to ppm of A. Similarly, ppm of B is equal to number of components of B in 1 million solution particles. So I can write this 1 million as 10 to the power 6. Okay, suppose if you are considering ppb, then this is equal to number of parts of A, number of parts, or you can say it as number of atoms or number of molecules, number of parts of A divided by 10 to the power 9. 10 to the power 9 simply indicates billion. 10 to the power 9 indicates what your billion. Now where these terminologies are used, okay, these terminologies are used in your filter water, or these are being used in your mineral water, Okay, if you see a packet of drinking water, there they will explain, okay, what is the optimum range. Okay, the iron should be present in your 100 ml of water, how much of silver should be present, how much of chlorides or how much of bromides. These all ions which are supposed to be present in drinking water for your metabolism of the body, they will be considering what? Million. For example, if you are considering fluoride ions, okay, if there are 1 million water particles, among them only one fluoride atom should be there. So this importance of fluoride you have learned in haloalkanes and haloarenes chapter. Okay, so there they say in parts per million, in 1 part per million, you will be having what? One fluoride ion. So these are the new concepts, okay, parts per million and parts per billion. So these two will be not used for your numerical basis, but we will be solving the numericals on mass by mass percentage, volume by volume percentage, mass by volume percentage, then molarity, then molality, then we will be solving the numerical on mole fraction. Okay, in your textbooks or kindly go through these definitions, and remember in your competitive exam, always remember they may ask you among these which are temperature dependent, which are temperature independent. If you want, you can write down the concentration terms, the one which are temperature dependent are 3, they are volume by volume, then molarity, then normality. So these are your temperature dependent terms, whereas temperature independent are okay, there are 4, that is mass by mass percentage, mass by volume percentage, then molality, then you are focusing on ppm or ppb, which indicates your parts per million or parts per billion. Okay, these all things are given in your textbook. Kindly go through these definitions and write down in a notebook. These will be helpful. Tomorrow we will be solving the numericals on these concentration terms. Thank you.